Hi, my name is Zaloga-Lakatosz. I study mechanical engineering at the College of Staten Island.
Hello, my name is Marjan Perbibaj and I study electrical engineering at the College of Staten Island.
Hi, my name is Sachin Mathew. I study computer engineering at College of Staten Island.
Most people will have back or knee problems at some point in their lives, and most injuries occur when bending over to pick up a load.
We designed and built a prototype for our senior design project that is here to help people with those problems, as well as to help prevent those problems from occurring in the first place.
So this system can raises and lowers a platform to a desired height. So it can be loaded and unloaded, and it is also attached to a pushcart for mobility.
Using this system takes the load off of your back and knees and puts it on the system. So we can show you a demo now. So imagine you just went to Home Depot and you got some wood and you want to come back home and you want to unload it. So what you're going to do is you're going to raise the platform to about the height of your trunk. And let's say that this is about the height of your trunk. You're going to want to stop the system. And you can picture that this piece of wood is sitting something like this. And instead of bending over the lift, what you're going to do is you're just going to slide the platform on and put the load on the system instead of lifting it up and carrying it wherever you want to go. You're then going to want to lower the system to its lowest position during transfer, just to make it safer when you're moving around, so it doesn't fall from a high height. So now you're good to go. You can move it wherever you want. And you're going to roll it over to where you want to go, and you're going to raise the platform up, whether it be to a shelf or something like that, wherever you want to store this item. You don't have to worry about stopping the switch at its maximum height or its minimum height. The code will automatically stop and sense where it is. This lift can go up to 3 feet in height, and its starting position is about 1 foot and 4 inches off the ground. I'm just going to wait for it to go all the way up. As you can see, the code is going to stop on its own. I'm not touching the control panel. But now you can move it to the stop position, and you can unload without having to bend over, and just move it a short distance to wherever it needs to go. That's lift assist.
So this is our user interface. As you can see on the right, we have our power switch, and next we have the 3-position toggle switch, which controls the direction of the lift, which is up, stop, and down. And next we have the 3-position rocker switch, which tells the program the weight of the load. Our prototype is designed to hold up to 5 kilograms. And finally, we have our LCD screen, which tells the battery level and the selected weight of the load.
So these are our electronics for the system. This is our 12-volt 18 amp hour battery connected to a fuse, which protects the circuit from an overcurrent. This is our NEMA 23 stepper motor, which has a pretty robust torque of 3 Newton meters. This is our controller, which is an Arduino Mega, which controls the system. And this is our stepper driver, which controls the stepper motor. And it's being cooled off by a computer fan.
This is our lift. Our stepper motor is coupled to a threaded rod that's 500 millimeters long and 16 millimeters in diameter. It's connected to a lead nut, which is connected to our drive bar. This rod has a lead of 5 millimeters, which means when the motor rotates one time, this drive bar will move one way or the other 5 millimeters. Our lift is in the design of a scissor lift. These braces here are constructed of 6061 aluminum, which is one of the most common aluminum alloys. They're 16 inches long, 1 inch wide, and half an inch thick. They're connected together using threaded rods and nuts, In between the nuts and the braces, we have spring washers, which will help reduce the friction, as well as bushings inside. This is our platform. It swings open and close, so we can provide maintenance to the system as well as grease the rod. The platform is 18 inches by 24 inches. Once the system was fully functional, we tested the battery and system performance. So these tests were taken from a full charge of 13 volts on the battery to a safe cutoff voltage of 11.66 volts, which is about 30% of the battery's full charge. A full cycle is a full extension up and a full close down of the platform. With a light load of 1 to 2 kilograms, a full cycle takes about 31 seconds. The battery lasted 6 hours and 40 minutes at about 775 cycles nonstop. With a heavy load of 4 to 5 kilograms, a full cycle took about 2.5 minutes. The battery lasted 4 hours and 10 minutes at about 100 cycles nonstop. Some conclusions that we had is that the system is most efficient, lasting the longest and doing the most amount of cycles at its lightest load setting. But the system is most practical at its highest load setting. It could still do 100 cycles on a single battery charge. The real system would be modified to carry more weight, which would make it really useful in a variety of situations. If anybody has any questions or anything like that, you could post it down in the comments below.